Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem intersection of two sorted linked lists. It's an easy level question, and the company tags of this question are Amazon, Microsoft, DShaw, and Zuper, and the topic tags are linked list, sorting, data structures, and algorithms. So let us go through the question now. And before we start, this is the problem of the day on Geeks for Geeks. So given two linked lists sorted in increasing order, all right, it's been given that the linked lists are already in increasing order, and create a new linked list representing the intersection of the two linked lists. The new linked list should be made without changing the original list. All right. So this means that you must not tamper the data that has been given to you, and also you must make sure the order is maintained. And also the elements of the linked list are not necessarily distinct. That is also one of the points that need to be noted. And you must return the linked list in the same order that the nodes are actually in linked list 1 and linked list 2. So these are the examples. We'll see that in brief. And expected time complexity is O of n plus m, and space is O of n plus m. So we are not using any space in my solution. In this particular solution, it's O of 1. And yes, auxiliary like time complexity is O of n plus m. So, and the size of the linked list goes from 1 to 5000. So that is the reason we have not put any initial condition like if head 1 is null or head 2 is null. It's not actually needed because there will be one node for sure, and data can go up to 10 power 4. All right. So this is the brief introduction of the question. Now let us go through the test cases. So this is the example 1 test case that has been given. So 1, 2, 3, 4, 6 is the first linked list, and 2, 4, 6, 8 is the second linked list. Now you can actually see there are 3 intersection points. 2, 2 matches, 4, 4 matches, 6, 6 matches. So in the same order, return it. So 2, 4, 6. This will be the answer. All right. So this is the output. Same is the case in example 2. We have what are the intersection points? Only 40. There's no other intersection point, right? So there are no other nodes that are matching in linked list 1 and linked list 2. So that's the reason 40 is the answer. So I hope you people understood how are we getting this. Now let us frame the approach. Very, very evident, very, very easy, to be honest. Need not think much. So let us take this example itself. 1, 2, 3, 4, 6. Isn't it? And second linked list is 2, 4, 6, 8. So do the things that have been given, do the things that I've been asked to do. Go traverse each and every linked list. Okay. So I'll be starting at this particular point first, and here as well. All right. Now I see that 1 is less than 2. So there is a chance that 2 might appear in the first linked list in the right side. So I'll go to this particular point. So I'll come here. Now I see both of them are matching. So I'll put that particular node in my answer vector. So an answer node. So let us assume I'm particularly taking some node answer. Okay, node answer. Now my answer next would be this particular node, that is 2. So answer next would be let us assume but head 1 and head 2 both are same here, like both of the values are same, so you can put any of them, not an issue. So head 1, and now I'll be going to answer is equal to answer next. Okay, so initially let us assume there is something like this answer. Okay, answer, and it has 0 value, and now I'm putting head 1, so that is 2, and now I'm standing at this particular point. Okay, now this is my answer. Now I'll be again traversing. I see that this particular 3 is less than 4, so I'll go to 3 itself. Okay, and again I see 3 is less than 4. Again I'll go to the next. So now I see both of them are matching. So I'll again put this particular nodes to my answer. So it becomes like this 4, and now this would be the answer. Okay, this would be the answer. Update your answer every time that you are adding a new node to your answer linked list. Okay, now again come to see this. So 4 and 4 are same. You can actually traverse both the sides. Now you can come to this particular point 6. Okay, so initially it was here, and now we are coming to 6, and also you're coming to 6 here, and again you see both of them are same. So you can add this particular thing also to your linked list. So 6, and now this is your answer. Okay, now this is your answer. And now once you're completely iterating this particular both of this linked list, this one and this one, now you'll even come here and you see none of them are like matching. So you're done with the iteration of both of them. Now you see you have come to the end. Now your primary task is to, like this, your secondary task is to put a null node to the end of this answer and return this answer head. That's it. So you can initially store this particular in temp, so that you can return this, like you can return temp next, that is this particular linked list at the end. So return temp next. All right, temp next. So this returns this to address, and this whole linked list will be printed later by the GFG inside compiler. So this is what I have written. So node answer equal to new node of 0. So it will be having 0 value. So new temp like this temp points to the answer, like while head 1 and head 2, like both of them are defined. If head 1 data is less than head 2 data, then move head 1 to head 1 next. And if you find head 1 data to be greater than head 2 data, move head 2 data to head 2 to head 2 next. All right. So come to that situation where both head 1 data is equal to head to data. Come to this situation. You're actually coming to this situation because you're looking out for intersection points. So in that case, you'll be going to the else. And now you can put answer next is equal to head 1 or head 2. Both of them are fine. And answer equal to answer text. All right. So because once you have added some particular node, like initially it was 0, now you have added 2. Now for this 2, you need to add new node. So that's the reason we have to come to this particular point. All right. And now head 1 equal to head 1 next, head 2 equal to head 2 next. You're traversing further. All right. And now answer next equal to none. After the whole iteration is completed, now come at the end of the answer next, put none. So that will be having the end of the linked list, and written temp next, because temp next is this particular point, right? Temp next is this particular point, and this is the head of the linked list that actually been asked. So once if we return this, they'll be printing it. So that's the reason we are writing temp next. I hope you people understood. So the time complexity is O of n plus m itself, because we are traversing all the nodes, and space is O of 1 because we are not taking any external space to store this linked nodes or something. We are just doing the like taking the space for the thing that they have been asked for. We are not using for an extra space to solve this question. So that's the reason this is SC is O of 1 and TC is O of n plus m. I hope you people understood. It's very basic question. So, and also for your reference, codes in Java, Python, C++ are there in the description. Please go through them. And if there are any doubts, please feel free to comment in the comment section. All right. So thank you for watching, guys. Stay tuned.